In today's video, I'm going to be showing you how to optimize your server-sided tweens. So to get started, let's create a generic tween. So I'm going to create a part in the workspace, and I'm going to set this part's color to red. I'm going to set the size of the part to 222, and I'm going to position this part at 0, 5, -10, and I'm also going to anchor this part. And then inside of this part, I'm going to create a script, and I'm going to delete this print. And in this script, what I'm going to do is get the tween service, and then I'm going to create a tween info, and then I'm going to create the properties I want the part to be tweened to, and then I'm going to create the tween using the tween service, and then I'm going to simply play the tween. Let's take a quick look at the tween info. So it has a tween time of 3 seconds, it has a ease style of quad, it has a direction of in and out, and it will repeat for -1, which means infinity, and it has a reverse value set to true, which means that once it finishes tweening, it's going to reverse back to its start position, which will take another 3 seconds. And before each tween, it's going to have a delay of 6 seconds. If we now play the game, we should see the part tweening forward and back and waits 6 seconds and then tweens forward and back again. And this will continue to happen for infinity. If we go into the View tab and turn on Network Stats and look at our incoming overall kilobytes a second, we should see when the part is not moving, it's around 0.16. And when the part starts moving, it goes up to around 1.66. So we can see it goes down to 0.16, and once the part starts moving, it goes up to 1.66. So the reason why tweens that run on the server side consume so much network data is because the tween service is constantly updating the instance's properties. And every time the tween service updates the property, now the server must replicate these properties to all the clients. So the server sends a message to all the clients telling the clients the new properties for this instance. And this is why so much data needs to be sent while the instance is tweening. But instead of tweening like this, what we could do is send the tween information and the properties to the client through a remote event, and then have the client tween locally on their computer so that the server does not have to constantly send the updated properties over the network. So what I'm going to do now is this part that we created, I'm going to move it to the right, and then I'm going to duplicate it and move it to the left, and I'm going to set this one to a green color. And inside of these scripts, so inside the red part script, I'm going to change this to +5, and inside of the green parts script, I'm going to change this to -5. And so that we don't get confused, what I'm going to do is I'm going to name this part green, and also name the script to green, and name this part red, and name the script to red. And now, so we can see we have the red script and the green script. Now in the green script, what I want to do is replace the tween service with a module that's going to emulate the tween service. So to do this, first inside of server storage, I'm going to create a module script, and I'm going to name this module script local tween. And inside of this module script, I'm going to create a function, and this function is going to be called tween. And this function is going to work like the tween service's create function. So it's going to take in an instance, a tween info, and properties. So we can see we've created a function that takes in an instance, tween info, and properties. The next thing I'm going to do is when someone calls this function, it's going to call a remote event and pass this information to all the clients. So in replicated storage, I'm going to create a remote event, and I'm going to name this remote event local tween. And now let's get a reference to this remote event. So I'm going to say local event equals game.replicated storage dot local tween. And then I'm going to fire this event when we call this tween function. So to do this, I'm going to say event fire all clients, and I'm going to pass the tween, the instance, the tween info, and the properties. And let's now go back to the green script, and let's replace the tween service with the local tween module. So I'm going to delete line 1 and say local tween equals require, and then I'm going to pass the path to the local tween module. And then we're going to replace the tween services create function with the module's tween function. So I'm going to delete these 2 lines here, and then I'm going to say local tween.tween, and I'm going to pass the instance, the tween info, and the properties. Now, one thing to take note is we're using a dot here instead of a colon because the function does not use self. And another thing we have to do is we must change the tween info data type because this data type cannot be sent over a remote event. So to do this, I'm going to convert this into a table. So to convert this to a table, I'm going to do this and change this to this. So now, instead of sending a tween info data type, we're going to be sending a table that represents a tween info data type. So the green part calls the tween function, and then the tween function fires the event and passes on the information to all the clients. So let's now create a local script that's going to receive this event. So inside of replicated first, I'm going to create a local script, and I'm going to name this script local tween, and I'm going to delete the print. And the first thing I'm going to do inside of this local script is get a reference to the remote event. So to do this, I'm going to say local event equals game.replicated storage, wait for child, local tween. And then I'm going to connect a function to this event. So to do this, I'm going to say event on client event, and I'm going to connect this function, and this function is going to receive the same parameters as what we sent. So we sent the instance, tween information, and properties, and the client's going to receive the instance, the tween information, and properties. So now once the client receives this information, we're now going to use this information to tween the instance. So the first thing we need to do is get the tween service. So say local tween service, get service, tween service, and now we're going to use the tween service to create a tween and instantly play the tween. So to do this, I'm going to say tween service, create, and we're going to pass in the same instance that the server sent. And then because we converted the tween info to a table, we're going to unpack the table into a tween info new. So this is converting the table into a tween info data type. And then we're going to pass the properties that we want to tween. And then finally, we're going to play the tween. Now there's one last thing we need to change. And if we go back to the green script, and if we look at this tween function that we're calling, this gets called as soon as the server starts up. And we have not given enough time for the player to enter the game. So this remote event is going to be called before the player enters the game, and nothing's going to happen. So to allow for the player to enter the game, all I'm going to do is add a task wait and add a 5 seconds. And I'm also going to do the same for the red part before I start playing the tween, so that both the red and green part are in sync. If we now play the game, we should see both the local tween and the normal tween tweening together. And one thing we should notice is that the tween that runs on the client side is a lot smoother than the tween that's running on the server side. What I've done now is I've disabled the script inside of the red part and only kept the script inside of the green part enabled. So if we go back to view and network stats, and if we look at the overall incoming kilobytes a second, where before when the red part moved, it went all the way up to 1.66. Now we can see that the kilobytes a second no longer increases when the green part moves. So we can see it stays at around 0.16. So now that we've seen the benefits of tweening locally, let's complete our module script. So currently we're just sending an event to the client, passing on the instance, tween information and properties, but this has some problems. Now to demonstrate these problems, what I'm going to do is inside of Workspace, I'm going to create a part and I'm going to set the size to 2, 4, 2, and I'm going to set the position to 0, 2, -10, and I'm also going to anchor this part, and inside of this part I'm going to create a proximity prompt, and I'm also going to create a script, and I'm going to delete this print. And the first thing I'm going to do inside of this script is connect a function to the proximity prompt's triggered event. So to do this, I'm going to say script.parent.proximityprompt.triggered, and I'm going to pass a function. And inside of this function, I'm simply going to tween the green and red part. So to do this, I can just copy and paste the script that we created inside of the red and green part. So I'm going to copy and paste this here. But I'm going to remove the task wait, and I'm going to move this section of the code into the event. And I'm going to do the same for the green part. So I'm going to copy and paste the green part's script over here, and then I'm going to remove the task wait, and I'm going to move this part into the event. Now I'm going to make a few changes. So one change is I don't want it to always tween to a position of -100. So I'm going to create a random value. So I'm going to say local value equals math.random, and it's going to be a value between -100 and -10, and it's going to copy this value and replace this to -100. And the next thing I want to do is change the tween info. So instead of tween for an infinite amount of times, I want it to repeat 0 times. So I'm going to change this to 0. And I don't want it to tween in reverse, so I'm going to set this to false, and set this also to false. And I'm also going to set the delay to 0, so there's no delay. And finally, I need to not use script.parent because I don't want to tween this part, I want to tween the green and red part. So this is going to be workspace.red, and this is going to be workspace.green. And if we wanted to slightly optimize our script, what we could do, instead of creating the tween information every time the proximity prompt is triggered, we could just create it once at the top, like this. And if I name this tween info 1 and tween info 2, and then change this to tween info 1 and tween info 2, and that should be a little bit more optimized. And finally, we no longer need the red and green script because we're only going to be tweening within this script. So I'm going to delete the green and red scripts. And now I'm going to go to test, and I'm going to start a local server with 1 player. I now have the server running on the left side and the client running on the right side. And if I go and trigger the proximity prompt, we can see that both parts tween for the client, where only the red part tweens for the server. And now the green part is no longer in sync between the server and the client. So if we now go into our module script inside of server storage, and we should see the modules tween function. And currently this function is simply sending an event to all clients with the tween information. Now what we want to do is, once we've sent this event, we want to work out how long this tween is going to take using the tween info, and then we want to set the instances properties to the properties table. So the first thing we need to take into account for the tween info is the reverse property. So if we go back into the script, and if we look at the reverse property, which we've set to false, now what this reverse property does, it will tween the instance to the properties, and then it will tween it back to its original properties. So if reverse is set to true, there's no point in setting the properties because it will go back to its original properties. So what I'm going to do here is I'm going to say if tween info, and I'm going to use the 5th index, which is this one over here, 1, 2, 3, 4, 5. So if the 5th index is equal to true, we're just going to simply return, and we don't need to do anything because the server will still be in sync once the tween ends. The next thing we're going to check from the tween info is the repeat account. So if we go here, we can see we currently have a value of 0, but if you remember, if we have a value of -1, then it would repeat for infinity, so the tween will never end. So we want to check to make sure that it's not -1, and if it is, we just want to return do nothing because the tween is never going to end. So to do this, I'm going to first create a variable called repeat count, and I'm going to say equals to tween info with index 4 because this is the 4th index, and I'm going to say if this value is equal to 0, then we're going to use the default value of 0. And then I'm going to check this variable, and I'm going to say if repeat count is less than 0, then just return and do nothing. So now in order to calculate the tween time, what we need to do is we need to add the delay time plus the tween time, and we need to multiply it by the repeat count plus 1. So if we do 0 plus 3 equals 3, and then 0 plus 1 equals 1, so 3 multiplied by 1 equals 3. So this tween should take a total of 3 seconds. So let's now do this in our module. So the first thing I'm going to do is get the delay time. I'm going to get index 6, but if this has not been set, we're going to use the default value of 0. And then I'm going to get the tween time, and this is going to be index 1. And if that has not been set, we're going to use the default value of 1. And now what I'm going to do is create a function. So let's create a function. And this function is going to be called tween ended. And this function is going to receive the index and properties. And now we're going to use task.delay to call this function once the tween has ended. So to do this, I'm going to do task.delay. And here we can see we do delay time plus tween time, and we're going to multiply it by a repeat count plus 1. And it's going to call the tween ended function, and we're going to pass the instance and properties to this tween ended function. And inside of the tween ended function, what we're going to do is loop through every property inside of this properties table and set that property onto the instance. So to do this, I'm going to say for index property in properties do an instance. I'm going to use the index as a key, and I'm going to set it to the property. So I've created a local server once again, and let's see how the tween reacts on the server side. So if I go and press E, we can see both the green and red part move on the client side, but for the server side, the green part only moved once the tween ended. So if I press E again, we can see the red part moves, and once the tween ends, the green part's properties are set to the properties table. And now we can see that the client and server go back into sync once the tween ends. We now have another small problem in which if I start the tween and before the first tween manages to finish, start a second tween, the first tween is going to get cancelled. But on the server side, because we're using task delay to call the tween ended function, when we start the second tween, the task delay does not get cancelled, so the tween ended function is still going to get called. So let's now see what would happen if I trigger the proximity prompt a second time before the tween has had a chance to finish. So I'm going to press E and then E, and now if we look on the server side, we see that it moves and moves twice, where in fact the first movement should have got cancelled when we started the second tween. If we go back to the module script inside of server storage, and what we want to do here is task delay is going to return a thread, and what we can do is cancel that thread in order to prevent it from calling the tween ended function once the delay has ended. So to do this, what I'm going to do is at the very top is I'm going to create a table called threads. And then when we create the thread using task delay, I'm going to store this thread inside of this table. So to do this, I'm going to say threads instance equals, and I'm going to use the instance as a key for the table. Now, once the tween has ended, I want to remove the thread from the table. So to do this, I'm going to say threads, and using the instance as a key again, equals nil. So here we add the thread to the table, and here we remove the thread from the table. Now, what I want to do now is when we call the tween function, I need to check to see if there's already a thread running for that instance. And if there is a thread already running, we need to cancel it before continuing the function. So at the very top of this function, I'm going to say if threads instance is not equal to nil, then cancel the thread and then set threads instance back to nil. And if we now test the game, and if I keep pressing E over and over again to cancel the previous tween, it should also cancel the previous task delay. So the green part should never move until the final tween ends. So I'm going to keep pressing E. And we can see that the green part never updates because the previous task delay is getting cancelled. And then once I stop pressing E and allow the tween to end, then the final task delay does not get cancelled and the properties were copied over to the instance. So let's now have a quick overview of the entire project. So inside of Workspace, we have a part with a proximity prompt and a script. And this is this script over here. And what this script does, it uses the tween service and it uses our custom module to tween both the green and red part. The tween service is used to tween the red part, while the module is used to tween the green part. And then when we call the tween function in our module, what this function does, it first checks the threads table to see if there's any threads relating to this instance. And if there is, it will cancel that thread and set it to nil. Then we send an event to the client, passing the instance, tween information and properties, and then the client will receive this information inside of this local script, which is in replicated first. And when the client receives this event, it will use the tween service and the properties that we pass to it to tween that instance. Then what we're going to do is we're going to use the tween information to calculate how long this tween is going to last. Then we're going to use that time to use task delay to wait, and once the tween has ended, we're going to call the tween ended function, and then the tween ended function is going to remove the thread that was added to the threads table when we called task delay, and then it's going to loop through every property inside of the properties table and set that property to the instance. Thank you for watching my video, and if you have any more questions, feel free to leave a comment down below.